Okay, this is going to be a little bit of a different video, and the reason that I'm making this video is that I have usually on this channel made videos about weather anomalies, and I've stated my opinions and thoughts, perspectives based on data, and I usually state the fact that I'm not a meteorologist, I'm not a climate scientist, and so forth. I'm a data analyst, and I look at well, I'm trained to look at a lot of data and make logical conclusions just based on what's in the data. Okay, so but the thing is that when you do this and you create a few videos and every one of them is pointing out anomalies, it's easy to lose perspective on what really happens when you're doing data analysis. And so I thought I would, in other words, I show you all the things that I find, things that I think are unique, that stand out, that are worthy of mention to help to create sort of a context or perspective for you. But I don't show you the things that I look into that wind up, in the end, not being true, not being significant. And there's a lot of them. In fact, most of the things that I look into with a little bit of research, it becomes clear that it's not what it's been stated to be. Now, all right, so I got two examples here, and the first one we're going to look at is an anomaly that I've been looking at for maybe 6 months or so. It's been happening, probably been happening longer than that, but was when it first came to my attention, and that is extreme low tides. And these have been, photographed, and a certain amount of data has been collected to show that it's real, and that there are places on the ocean that have these very bizarre, very, very low tides. Maybe I'll create a video on that, but at some point. But it's interesting, and the reason I haven't made a video yet is that I can't explain it. I don't know, why it's happening, where the water's going. There's reports out showing the Mississippi River, being significantly lower, and that kind of thing at different times of the year. So I don't know what's causing it, but I continue to look into it, right? And so I don't share that data. And so here I'm going to share a situation where it would seem or appear to be an extreme low tide, and I'm going to show you why I don't believe it is, and a couple of things that jumped out of during my research to help me decide that, and then also everybody likes UFO stories, right? And everybody likes the mystery surrounding Antarctica. And recently I ran across a really interesting story about a UFO that apparently landed on a little island down around Antarctica. And so I'll show you that, and I'll step you through a little bit just real quickly to show you why I don't think it's a UFO. But anyway, it's kind of fun. And, I've seen UFO stuff that kind of makes you scratch your head and go, maybe, and so forth. So anyway, let's do this just real quick. And if you want to take a minute and kind of get a little insight into how this kind of research works. But there was a report recently. There was a nor'easter, and if you live in the Northeast United States, you witnessed this or experienced this. But a giant storm that came up and caused flooding and a lot of power outages and so forth came right up the east coast of the United States. So down here in North Carolina, there was a report of an extreme low tide. And so I went and started checking it out. And if kind of, there was a unique one when there was a hurricane that came through up in the Gulf of Mexico. It came up Florida and down around Tampa Bay area. I believe it's right here. I think this is Tampa Bay area. The tide rushed way out in an unexpected way. And they said that it was because of kind of a suction that happens in the backside of a big storm like that. So there was reports to explain the low tide that said the same thing happened up here in North Carolina. Sorry, it's right around here. And so if we zoom in, I'll give you an idea of the location. Let's It's here, I believe. So you can see how shallow this is already up in here. And there's the Pamlico River, and this is the Pamlico Sound. If we zoom in a little more, there it is, Pamlico Sound. But you can just see, right, that this is kind of the ocean out here. There's this little string of islands, very shallow in here. So low tide is going to be, you know, to someone who doesn't know better, it's going to be extreme in this entire region. But if we go up in the river, this is kind of the mouth of the river here, well, it's going to be even more extreme the further up you go. The report was at a place called Swallow Bay, which I believe is right here. Right here. Yeah, this is it. Sparrow Bay. Sorry. Sorry. So there's Sparrow Bay. All right, and I've got it in satellite view, and I'm going to show you the pictures. Okay. So, yeah, but that's actually water out there. You can see the white caps. And so this looks horrible to kind of the untrained eye. I've never been here, so it looks extreme. I see tires. You know, this looks like, oh my God, that must be unique. Somebody would have cleaned that up, right? I don't know. Here's kind of a boat ramp type thing that people do in these shallow water areas so they can get their little, you know, smaller boats out and things like that off their property. And a seawall up in here. So, I'm gonna, yeah, okay. So let's click through these and see if we see any anomalies. Now, one thing I see a lot in these pictures is boats that are beached, and sometimes that's normal, but there are certain things that make things look abnormal, and we'll see one here. But here's another one, and these piers are usually designed so that you know, you can get your boat. That's why they're so long. Even at low tide, you can get your boat up to the pier. Well, not here. So this is, you know, an extreme tide. But is it unique? And we go down. All right, look here. All of these piers. But that's water out there. Okay, so it's very low, but it's not like the whole, the river's still going out here. It's not just a creek. It's not just a, you know, a real narrow band of water moving out to the ocean or to the sound. But then we go here. Does this picture look different? I'll point it out if you don't catch it. But see these boats? Now this would ordinarily look like an extreme tide event, because a sailboat, you don't want to do this, right? They have these long kind of fins on the bottom that keep them upright with your sail pulling against you and so forth. So you don't want this to happen. That could damage your sailboat. But this is not a very high bridge. So, you know, tide, okay, I don't know, it looks low. Sometimes people just tie their boat up. Maybe they're rookies. Maybe they don't know better, whatever. And, you know, the tide went out. And so I have to keep that in mind. Also, this group of pictures is all about the wind. You know, and so when they talked about how the nor'easter pulled the water out of this river and all that kind of stuff, right? But look, March 2nd is when this is posted. Look at the leaves. Does that look like March to you in North Carolina? That looks like September, October. Leaves are falling and things, but there's no way this is March 2nd. And this, by the way, if we go back, does not look like this at all. So I don't know. I don't know where this is. Maybe it's in the area, but I don't believe it's March 2nd or 1st, you know, or whatever. This is way months ago, and you can even see that here. Look, a commenter, I questioned the date based on the color of the trees. So, so that right there to me kind of invalidated all these pictures. So where are we? You know, are we out close to the sound, or you know, are we even on this Sparrow Bay? Well, let's take a look. It's not hard. And again, I'm just doing this to show you how this research kind of works. So if we come in, we can see Sparrow Bay Road. All right, so this is Sparrow Bay out here. And there's not many options. Is that photography? Okay, and I mean, really, this is the end of it. This is the end of the bay. So it's somewhere right in here. And of course, I notice this really, really long one here, kind of pier, dock. And what do we see? How can we identify it? We've got what it looks like a boat ramp. If I can zoom in, yeah, there we go. You can see the boat would pull in from the deep water like this, not this way, but this way. You can see there's a little dock on the side, or a pier that goes off to the side, and it's very long. And so we'll see if we can see that in the picture. Now, this first picture, you can see that the seawall comes along, it juts back, and we've got trees here, right? So it's kind of the end of that sound. So let's go back and look at our picture. That's what this is. Seawall comes along, it juts back, and we got trees. All right. So I'm suspecting there's docks on down there, just like it is. Let's go to the next picture. All right, this is the exact same thing. The trees are right out of frame here. So this was in the previous picture. Let's keep moving, just for the sake of time. There's our pier, and you can see the green. There's the boat ramp or dock. They put their boat on that and lift it up out of the water, and it's facing the right direction. It's off to the left, pier to the right. Okay, this is looking like that dock I was pointing to. Let's go to the next picture. All right, so we're looking down this way now. And we see 1, 2, and the third one has got a boathouse on it. All right, let's go to maps. 1, 2, what do you know? All right, so this person was standing right in here, somewhere right up over in here. All right, that's where they were taking the pictures from. So let's back out, and you can see how wide. I mean, this is a really big span here. And at low tide, how far out could this go and still have a lot of river area? A long way. All right, and look, water out here. So this is low, but it's not that low. What else do we do with research? Well, we have to look at time. March 2nd, what's significant about that? Well, the full moon is on March 1st. It wasn't just a full moon, but look, we're not looking at a time of year when the moon is way away from Earth. So there are times when the moon is closer to Earth and further away and so forth. So it's not exactly a supermoon. So the moon's not at perigee, it's not at its closest point, but it certainly is closer than usual. And we had a nor'easter blow through. We know after that tides go out further. This is not a significant tide, and that's the point I'm trying to make. Okay, so interesting to look at, but not a part of an anomaly, because we have seen some, and again, maybe I'll create a video, but there's some that just really are hard to explain. The tide goes way out, way out, and it stays out for 18, 19 hours, so it's not even on a tidal pattern. Last thing I looked at here, just to check, right? Is this normal? I don't know. I'm not from there. But I can look at the tidal records. And here we are on Friday the 2nd. Okay? And these are normal tides. I can go to the 1st. Let's assume maybe they took the picture the day before, and this was the full moon, right? Let's let this load. And there we go. Nothing unusual about the tides. So the data does not align with the fact that it's an anomaly. The location, well, where is it? I guess we didn't really look at that, but look, it's way up here toward the end of this mouth of the river. So at low tide, it's going to be more extreme the further up you go. There's that sound. So yeah, it would go out a long ways anyway. And then, of course, because it's a full moon, at the time when the moon is close to perigee, close to the Earth, it's a daytime picture, so the moon's on the other side of the Earth, which means low tide. Yeah, okay. That makes sense now. We had an extreme low tide. Okay, so again, ordinarily in these videos, I'm showing you things that are anomalies, but more times than not, what I find are things like this that really can be explained. And unless I get like a report from a local person or a news organization of some kind, saying that this is some kind of an extreme, never before seen kind of an anomaly, then this one, nothing unusual. Maybe it's unusual, but nothing to track as being really outstanding and a possible part of a global trend of super low tides, right? It just happens that way. And this kind of thing happens a lot of places. A lot of places are very well documented up in Nova Scotia and so forth, Baja Peninsula, where there are extreme low tides. All right, this is one of them. It's a river that comes in, and so this whole area is prone to low tides, very, very low tides. All right, so there's that. Let's look at another one, and the other one, I can do it here. Let's see, how do I want to do this? Let's go to, all right, I think the reports I saw online used let's get out, used Google Earth here, and I'll show you, this is it, but let me show you where we're back in again. All right, here we are. Let's talk about UFOs. Little green men in cigar-shaped spacecraft landing on Earth, crashing on Earth, nonetheless. But here's Antarctica coming up. This is Brazil, Argentina, that kind of thing. And so we have this fault line where there's some interesting, earthquake activity happening now and so forth. And so as I was studying the earthquake activity, I ran across this report about a spaceship that crash landed here. And ufologists are kind of going nuts and so forth. So let's zoom in. Here's this little island, South Georgia Island. And let's see, we look for that. Look for this. So it's right over here. Let's see if it starts to jump out at us right here. All right, see this little mountain and how this corner is collapsed in? You zoom in. See anything unusual yet? No? Zoom in a little more. Look at this. Look at this, a debris field. So it's like a spaceship came down and clipped this mountain, caused a collapse. You can see the debris field, and it came skidding in here and came to a full stop, and there's clear evidence of a cigar-shaped spacecraft that crash landed in the snow. Okay. Well, let's look at this. If I go in here and pull up my ruler, and I'm in Google Earth. Oh, I guess the first thing is, look at this. This is 2010, if you look in the lower right corner. 4/20/2010. And then I'm like, oh, okay. And these guys, they were saying, look at this, look at this. We can see. Boom. We can see where they're hiding something, right? Because if we go down here, there's our little island. All right, we zoom in, and now we're looking at, we went from Google Earth to Google Maps, right? So, same stuff. We zoom in here. There's that, it's right over here. There's a little mountain, and we zoom in. All right, and there's our little spacecraft. And look at this, 2018. Are you telling me it hasn't covered with snow? This is obvious cover-up. They've doctored these images. They're using old images. Okay, look, Google, they're not putting up new maps of an island that's totally uninhabited, with no significant changes, no volcanic activity. It costs a lot of money to keep these things up to date. So where there are no changes, no population, and it wouldn't help really anybody to have up-to-date free imagery. I'm sure you can get live satellite or recent satellite images if you were going to go hiking or exploring on this island, but that's not what this is all about. So to point out the date and talk about that as some kind of sign, that's just, right out of the gate, kind of red flags going off. People don't know what they're talking about. But let's look at this cigar-shaped spacecraft and do a little playing around. So I'll pull up my ruler. What we want to do is, let's see how wide this track is. Okay, we go boom, boom. I don't think it makes sense to do miles. Let's go to feet. All right, so it's 25, 25, 30, let's just say 30 feet wide. 30 feet wide, that's pretty wide. I mean, it really is, right? But that is a huge avalanche that came off this mountain and caused this debris field. So you can imagine some giant boulders probably came, rocketing down this mountain for sure, right? So next piece of data, let's clear this, and let's just say we'll assume the end, and I'll tell you why in a moment. And we'll go all the way up here. That trail starts right, let's just say in here. Boom. All right. Yeah, okay. You know what? We can go, some people like yards. Let's look at it in yards. Okay, 1,200 yards. Let's go to miles. All right, 0.68 miles. So, over a half a mile. That's a long, long ways, right? So, first of all, that's a long way. If a spaceship, if something, was coming fast enough to crash from space, the damage it would do here would be huge. And this, it looks like, let me close that. It looks like something kind of, dare I say, rolled. Have you ever rolled a snowball? It looks a lot like that, doesn't it? I mean, this is the kind of way you have to look at these things. Until you find something that really, if you do any of this, until you find something that you cannot explain other ways. I mean, there's only one way to explain it, and that is the conspiracy theory or the whatever. Then you have to assume this is natural, even though it is unique. What else do we notice here? All right, that's obviously an avalanche, right? That's a collapse from this mountain. But look at the terrain. Downhill, downhill, or really steep downhill, downhill, downhill. And then it comes over here. In fact, we can do this kind of fun thing. We can actually, push shift and go like this. We can look at this thing. Look at that. Isn't that cool? I mean, look. You can see that thing. It's not even a straight line. So what a strange thing for a spacecraft to do, right? It came down. It rolled this way, just like if you play golf, you recognize this. Okay? So it broke this way, broke left from this perspective. And it went down, then it came up this little hill. There's a little drift here. And it went over, and then it came, see the curve? And then it turned back to the right, just coming down the back side of that. And then what's this here? Can you see it's a low area? Let's see, if I go like this, and I pull back, you can see it really good. See how you got these little humps, these ridges, right? So there's a hump out here. Look, it came right down the valley, and what happens here? That valley turns. And so that snowball, or rock covered in snow that's 30 feet wide, came rolling, probably flying down that mountain. It rolled up, it rolled over that little hill and down right into the valley, and then it plowed into the snowbank because it couldn't turn to keep going down this way. Does that make more sense than a spaceship crashing on Earth? Look at that. You can just about see where it started plowing in, and then it just tunneled its way and came to a full stop right there. It was a round-shaped object that came to a stop under the snow. All right, so anyway, enough on that. But I thought that was kind of a funny one because it does look unique. A lot of people could be fooled by that, but I think the odds that is a spacecraft buried in the snow are, let's just say, remote, no pun intended. On a remote island down near the mysterious Antarctica, where strange things do actually happen. All right, so anyway, I hope this was kind of fun for you, interesting for you, and it's just a different way of looking at data. When people say, oh, you don't know what you're talking about, I'm not arguing that. Again, I'm not a meteorologist. I'm not a geologist. I'm not a scientist. I look at data, and I do analysis. That's what I do. And so I'm looking at the data. And if somebody has some data that tells me I'm wrong when I look at things like CO2, I am totally open to the idea that maybe CO2 is causing massive climate change. It's just that all of the data, all the real data, and you don't have to dig very deep, makes it look completely ridiculous that anybody would actually even think it made sense to ponder the idea that a human-caused CO2, or the human contribution of CO2 in the atmosphere, would have any significant change on anything. And so I take that position. Now, what do I see? Because I talk about these changes a lot, and it just seems to me, and I'm not going to go into great detail on my theories because I don't think that's necessarily relevant. But I will tell you that it just seems to me that something in space, something about space, something. It could be the sun, and there's data showing that the sun is changing. Of course, we're going into a grand solar minimum. It's been, a long, long time since this has happened before. We didn't have the spacecraft up. We didn't know everything we know today and so forth. Last time we went into a minimum like this, that's an effect. But what's the cause of that grand solar minimum? Could be a lot of things in space and factors. Something in space is affecting our planet, and this is just what the data is leading me to. It's affecting the planet in a way that, you've heard about pole shift in the news. What causes that? And they've got some explanations, but they're all theories. And even if you accept some of the theories, you have to acknowledge the question of why. Why is it happening? And then you look at all these other anomalies that are going on, weather patterns and so forth. It seems clear that something inside the Earth, like we're seeing more volcanic activity, we're seeing a lot more water temperature anomalies that seem to be caused from hydrothermal vents and things coming up from inside the planet, tectonic movement with earthquakes. We're seeing all these things that are well proven to affect, warm water heats air. Water's more dense, so a small change in water temperature can have a great change on atmosphere temperature, less dense air. The other way around does not make sense. So as I kind of just stay, full stop there, that's what I've noticed. And I do these research projects just in my own time to kind of, because of curiosity, look at these anomalies. If I start seeing extreme low tides, I'm going to start just kind of looking at them and checking the boxes where I can find little ways of saying, no, not that one. That's not unique. It's unique, but it's not a sign of something major happening on Earth, and so forth and so on. And then I see these things like UFOs, which are fun and interesting to look at, but quite often very much like what I just showed you in this video. So anyway, this is a different video for this channel, but when you're doing analysis and you're trying to tell people that what you're seeing is unique, it's a natural thing, particularly on the internet. I imagine most of the people that see these videos don't know me at all. How do you know to trust somebody? And so I thought it made sense to look at the other side. Let's look at a couple things. And most of what I do look at winds up in this category. It just gets really boring. If I did a video after a video after video showing that I'm debunking things that are, noticed on the internet, I could have one long channel with, like nonstop data. But that's not interesting. What I want to do is say, here's some patterns I've seen in the data. Here's some things that are real, that are happening. Could this be caused by CO2 in the atmosphere, elevated by man's activity on Earth? I don't think so. Those are the kinds of things that I want to focus on. And so, anyway, that's a couple of examples of things we see and things we hear, and the kinds of research you have to do to kind of fact check yourself, and that I do before I create a video. Sometimes things slip through the cracks, and if anybody sees something that I've overlooked or stated wrong, I always appreciate that insight, because we're always learning. With that said, have a great day.